By late 1944, the Pacific War had entered its final, most brutal phase. The strategic landscape had irrevocably shifted. The United States Navy and Marine Corps were pressing ever closer to the Japanese home islands. In this desperate crucible, the skies above Okinawa and the surrounding seas would witness a critical air combat duel. The American fought F-4U Corsair against Japan's Nakajima Ki-84 Hayate, known to the Allies as Frank. This was more than a clash of machines. It was a stark illustration of two nations' vastly differing capabilities in the waning months of a global war. While Japan's Ki-84 represented a significant technological achievement in design, its operational effectiveness was ultimately crippled by a combination of factors: crippling production limitations, a severe decline in pilot training, and the overwhelming industrial might of the United States. This allowed for continuous development and mass production of its own superior aircraft like the Corsair. The story of these fighters begins years earlier, with a clear strategic imperative. The U.S. Navy, foreseeing the need for a next-generation carrier fighter, demanded performance that would outclass any existing model. At the heart of this ambition was the colossal Pratt & Whitney R2800 double Wasp engine, delivering an unprecedented 1850 horsepower. This raw power would become the foundation for America's next generation of fighters. Vought chief engineer Rex Beisel and his team designed the F-4U Corsair around this massive engine. Its distinctive inverted gull wing was a functional necessity, providing clearance for the huge propeller and allowing for shorter, robust landing gear. On October 1, 1940, the XF-4U-1 prototype shattered expectations, becoming the first American fighter to exceed 400 miles per hour in level flight. It was a revolutionary aircraft, a testament to American engineering prowess, yet its path to dominance was far from smooth. Early F-4U-1 models, with their birdcage canopies and initial armament of mixed machine guns, suffered critical deficiencies. Test pilots, including Lyman Bullard Jr., reported a tendency for the port wing to stall suddenly on landing, poor visibility over the nose, directional instability during carrier approaches, and stiff oleo struts that caused dangerous bouncing. These issues led to the U.S. Navy's initial disqualification of the F-4U Corsair for carrier operations. Instead, it found its early combat deployment from land bases in the Southwest Pacific, entering action with VMF-124 in May 1942. Through continuous development, the Corsair evolved. Later improvements, including a bubble canopy for improved visibility, an extended tail wheel, a raised pilot's seat, and modified oleo struts, steadily addressed these flaws. A wooden spoiler on the starboard wing finally resolved the notorious stalling issue. The F-4U-1D variant featured under fuselage pylons for drop tanks and bombs, and eventually the armament standardized to 6 reliable Browning M2.50 caliber machine guns, 3 in each outer wing panel. A 20 mm cannon-armed F-4U-1C variant was also developed, though pilots often preferred the .50 ammunition capacity and rate of fire. As the war progressed, the F-4U-4 model, powered by the more potent Pratt & Whitney R2880-18W engine, delivering 2,347 miles per hour, achieved a top speed of 447 miles per hour. It could climb to 20,000 feet in an astonishing 5.9 minutes. Vought, along with Brewster and Goodyear Aircraft, built 11,484 Corsairs before the war ended, with Vought alone producing nearly 2,000 F-4U-4. This staggering industrial output demonstrated America's unmatched capacity for war production. Meanwhile, to Midie's unmatched capacity for war production, in Japan, the Imperial Japanese Army Air Force, or JAF, had also recognized the urgent need for a more capable fighter. Early combat experience, particularly against Soviet aircraft over Nomonhan, had challenged the JAF's initial doctrine, emphasizing pure maneuverability. They now demanded heavier armament, greater speed, and better pilot protection. Nakajima's Ha-45 Homer engine, delivering 1,800 horsepower, offered a substantial power increase over earlier Japanese engines. Under the guidance of Major Yoshitsugu Aramaki, Nakajima embarked on an unprecedented development strategy for the Ki-84 Hayate. To accelerate its introduction, Aramaki recommended producing 100 test examples, a number unheard of compared to the handful of prototypes for previous fighters. The first flight of the Ki-84 prototype occurred in April 1943. Test pilots were immediately impressed. The Type 4 Hayate was a larger, heavier, and more robust aircraft than its predecessors, featuring an all-metal stressed skin fuselage and wings. It boasted outstanding maneuverability, a superior rate of climb, structural strength, heavier armament, two 12.7 mm machine guns, and two 20 mm Maho 5 cannon, and better pilot and fuel protection compared to earlier Japanese designs. Captain Eric Brown, a renowned Fleet Air Arm test pilot, later praised the Ki-84's handling and performance. The Hayate, despite initial engine issues like excessive cylinder temperatures and oil pressure drops, was excessive for service in April 1944, just a year after its first flight. On paper, the Ki-84 Hayate was formidable. Yet, its story is one of tragic potential unfulfilled. For decades, the narrative of late-war Japanese air power often depicted universal inferiority. Yet, newly examined records reveal a more nuanced truth. An aircraft of genuine potential caught in a spiral of systemic decline. The Ki-84's effectiveness was fatally undermined by a combination of factors rooted in Japan's desperate strategic situation. By January 1945, Japan had lost the Philippines, severing vital resource lines. U.S. submarine campaigns had crippled Japanese shipping, leading to a third drop in aircraft production and a two-thirds drop in engine production. Crucially, oil imports had ceased. This industrial collapse meant that Nakajima, despite its best efforts, built only 3,416 Ki-84s by war's end. By June 1945, they produced 168 Ki-84 airframes, but only 150 Ha-45 Homei engines, highlighting the severe bottlenecks. The U.S. aviation industry, by contrast, built more aircraft in 1943 alone than Japan did in the entire war. More devastating than material shortages was the precipitous decline in Japanese pilot training. The JAF's training regimen, once comprehensive, was drastically shortened. From 400–500 flying hours for a fully trained pilot earlier in the war, this was cut to 9 months in 1944, and then to a mere 4 months by early 1945. Trainees joined frontline units with as little as 150 to 200 flying hours. This contrasted sharply with the extensive U.S. training pipeline, where pilots accumulated 400 to 500 hours by the time they completed operational training. Fuel shortages, a direct consequence of U.S. submarine blockades, further limited crucial flight time. This disparity in pilot quality was the Ki-84's Achilles heel. Even an advanced aircraft is only as good as the pilot flying it. JAF radio quality was notoriously poor, hindering coordinated action. While JAF doctrine had belatedly shifted from individual attacks to a two-airplane element as the basic formation, effective mutual support remained a persistent problem. U.S. Navy and Marine Corps doctrine, by contrast, emphasized core principles: superiority of position, disposition, concentration, and marksmanship. These principles, deeply ingrained through rigorous training, provided a distinct tactical advantage. As the war entered 1945, Japan's strategic desperation became absolute. With the impending invasion of Okinawa, Japan implemented Operation Tengo, a plan to defend the island through mass special attack units. Due to insufficient advanced fighters and experienced pilots, the JAF and IJNAF converted training classes into Shimbutai and Tokubetsu Kogeki Tai, or special attack units, for suicidal kamikaze missions. The Ki-84 Hayate, despite its potential, was often relegated to escorting these kamikaze formations or defending airfields on Kyushu. This commitment limited its ability to engage in optimal combat scenarios, forcing it into disadvantageous roles. A lack of adequate radar warning systems often meant Hayate pilots took off directly into areas where American aircraft were already waiting, losing the critical element of surprise and altitude advantage. The Battle of Okinawa, Operation Iceberg, commencing on April 1, 1945, involved 541, the mighty U.S. Navy Fifth Fleet, including Task Force 58, with 17 carriers. The U.S. Navy, anticipating the threat, had increased fighter numbers on its Essex-class carriers from 54 to 73. The F-4U Corsair, being 30 miles per hour faster than the F-6F Hellcat, became crucial for combat air patrols, or CAPs, to protect the fleet from the relentless kamikaze onslaughts. The first significant aerial engagements between U.S. Navy Corsairs and Ki-84 Hayats occurred on February 25, 1945, during carrier strikes east of Tokyo. Lieutenant Commander Roger Hedrick, an experienced Corsair pilot from BF-84, noted the Hayati's speed, but also the apparent lack of aggressiveness from Japanese pilots. On March 18, 1 Prange Tuitin, 1945, VMF-221 encountered a formation of 25 Japanese fighters, claiming 8 Zeks and 5 Franks shot down. As the Kikusui operations, the mass kamikaze attacks, began on April 6, 1945, the Hayati units were fully engaged. On May 4, 1945, Major Michiaki Tojo, commanding officer of the 103rd Hiko Sentai, leading Hi-8 escorts for special attack aircraft to Okinawa, claimed 2 F-4U Corsairs shot down. One of these, Lieutenant Saul Chernoff's Corsair, was damaged. This demonstrated that, in the hands of a skilled veteran, the Ki-84 remained a potent threat. However, such instances were increasingly rare. U.S. Marine pilot Captain William Snyder, an ace with 11.5 victories including Franks, exemplified the well-trained Allied pilots who consistently outmaneuvered and outfought their Japanese counterparts. Second, Lieutenant Stuart Alley of VMF 323, for instance, successfully engaged and destroyed a highly aggressive Ki-84 pilot, demonstrating the Corsair's capability in a direct challenge. Lieutenant CDR Hedrick's post-war reflection captured the prevailing sentiment. The F-4U-1D held a not large but ample edge over late-war Japanese fighters. One persistent challenge in assessing these engagements was aircraft identification. The Frank resembled the Oscar and Tojo, leading to frequent misidentification by Allied pilots. Claims of Tojos or Oscars shot down were often, in reality, the more capable Ki-84 Hayats. Historical analysis, therefore, requires caution and scrutiny of aircraft action reports. Nevertheless, U.S. Navy statistics showed claims of 28 Franks and 53 Tojos shot down by Corsairs. Even with potential misidentifications, the estimated ratio of Japanese fighters destroyed to Corsairs lost was roughly 7-1, a clear indicator of Allied air superiority. The final combat encounters between the Corsair and the Hayate likely occurred between February and July 1945, with the F-4U-4 making its combat debut against a Frank on June 21, 1945. By the war's end, Japan had lost approximately 3,000 aircraft during the Okinawa campaign alone, including 1465 special attack aircraft and their irreplaceable crews. The Nakajima Ki-84 Hayate, despite being a formidable aircraft, remained a footnote in the war. It was a technically brilliant design, a testament to Japanese ingenuity, but it was ultimately undermined by systemic failures, a decimated industrial base, crippling fuel shortages, and a drastically reduced pilot training pipeline. The duel between the Corsair and the Hayate is not just a story of two aircraft, but a powerful illustration that in modern warfare, technological superiority alone is insufficient. It must be supported by overwhelming industrial capacity, robust logistics, and a highly trained and well-supplied force. The ultimate outcome of the Pacific War's air battles was determined not by individual brilliance, but by the grinding, unstoppable might of a nation fully committed to total war.